Okay, so I'm re-recording this spring 2023 that StatCrunch calculator. I've been watching my older videos. My StatCrunch calculator doesn't work sometimes in some people's computers, and my Oxbow stat students found this other one that they like, and it does the same thing. So I'm going to walk you through it. So in case you haven't seen all my other videos about binomial probability distributions, go watch Dr. Stevens. He does a fantastic job about using the formulas, using the probability tables, and they work slick. And you're welcome to use those. Sometimes the formulas, it takes a lot. Like when we're looking for like the probability of X being greater than 7 when there's 20 trials, that's a lot of calculations. And this calculator takes that away. Yet it's not any easier. Well, the calculation's easier. The interpreting it's just as hard as the other one, but without the manipulation. So when you're dealing with the binomial probability distribution, you want to ask yourself 4 things, and it's these 4 things right here, right at the top of, right at the top, page 71. Are there a fixed number of trials, or is each trial independent? In other words, does my some event happening affect the event happening in the future? It's or that's so each trial has to be independent. Each trial has yes no answers. If there's more than two outcomes, it's not a binomial distribution. And then the probability doesn't change. So these are kind of the same ideas, but not necessarily. And it'll come up. I won't go more into that, but you got to check these 4 things to make sure it's a binomial distribution. Because when we come to chapter 6, end of chapter 6, you got to make sure the distribution is a binomial distribution before we're going to do it next. Okay, and of course he'll walk you through all these pages if you go watch his video. And here's that formula, and this is exactly one outcome, and I'll show you how that works. Okay. Let's use that GigaCalc calculator for this one. So this is the one I have linked. This in the the online tools. That's the calculator I have linked. And let's see. I better write this down because I'll never remember it. Let's see. So this is we have 15 trials. It's the 15 question test, and there's 5 options. So the probability of guessing correctly is 0.2. At this 1/5, right? And then we want to suppose you want to guess what's the probability that we get exactly 2 correct? What's the probability that exactly 4 correct? What's the probability of, well, let's see. I'm making this one up. Let's see. Passing a test is a 60. What's 60% of 15? So that's 9. Probability of getting 9 or more is what we'll do. And I'll write this on the screen here in a minute. Okay, so we'll do this. You can come back and see the answers. I probably won't come back to this screen. Let me come up. I guess I gotta pause this video for a minute. Okay, so let me get some stuff on the screen all right, let's see here. So I know that there's 15 trials with that test question, or 15 questions in the test. The probability of guessing correctly, because there's 5 outcomes, so 1/5, so 0.2. And we want to know the probability of getting exactly 2 correct, the probability of getting exactly 4 correct, and the probability of getting 9 or more correct to pass. Okay, and we'll talk about how to get this stuff out of your calculator without having to do all that work. Maybe what I'll do here, give me a minute. Okay, so first off, why do we have to make sure that it meets those conditions? Well, what happens is here's what these distributions look like. 15 trials, the probability of success is 0.2. You're going to use a different calculator. This one works, but it's not it's kind of limited in what it can do. So what we're doing here, what we're trying to find is so here's the distribution of guessing of the getting anywhere from 0 questions right by blind guessing to as many as you can see. The probability of getting 15 is right off the chart. Probably getting 7 right. The probability of getting exactly 6 right is that. Okay, so what we're really doing is just finding the area of a bar, how high one of these bars are. That's why it's a discrete probability distribution, because it's not like, remember, it's a continuous quantitative variable like on the exam. So this is just these are discrete outcomes, discrete variables. And we'll look at continuous in chapter 6. During week what is that, week 7 is it? And so here's what the different probabilities are. And if they're exactly, if I want to know what's the probability of getting exactly 2 correct, that's it. Exactly 2, that's the probability. About a 23% chance of getting exactly 2 correct. And then probability of getting exactly 4 correct. See, we're looking for that bar. So now for the last question, I was asking, what's the probability of getting 9 or more correct? Guessing 9 or more, and this calculator will let us do the inclusive part. So the probability of guessing, just blind guessing and passing this test, 60% or better, is a very small probability. Now, if you think back to chapter 4 in the probability distribution, I'm not probably there in distributions. The raw probability, if a probability of event is less than 5%, we consider that unusually low, unusual, right? So this is definitely unusual that you'll pass a test just by blind guessing. The other thing we could do, and while I'm thinking about it, this is a skewed distribution. This is specifically a right skewed distribution. So to talk about the center is red, we really should be talking about them using the median and the IQR, which we don't want to find that. Okay, so but we really can't use the standard deviation idea here, the mean, the standard deviation, because this isn't a symmetric distribution. We have, just so you know, I'm going to kick this down the road. If we have something like a 40, you see how if it's a 40 trials, a 40 question test, see that's a little more symmetric. We could probably use the mean as standard deviation. Notice it gives us that on this calculator, which it's easy enough to calculate. You don't need to use a calculator for that. Though you can, it's not wrong. It won't be wrong if you do. But that's more of, that's at the end of this chapter 6, where we start talking about that. It's got to meet certain conditions. The conditions that need to be met are that n times p has to be bigger than 5, and n times 1 minus p, or n times q, has to be bigger than 5. And we could do some guessing here. Notice I don't even care about the x in this case. N times p, 40 times 1/5 is 8, and 40 times 4/5 will be bigger than 5. So, and this is close enough to be called a normal distribution. We can, or symmetric distribution. We can use the mean and standard deviation, talk about unusual events. Just this is why that part at the end of chapter 6, about using the mean, the standard deviation. This is why you got to do that condition check, that n times p has to be bigger than 5, and then n times q, or 1 minus p, has to be bigger than 5. Because if that's not true, it's not a symmetric distribution. Okay. So enough of that. I was digressing. I really wanted to show you how to use that other calculator. It looks like for the questions I set up and pulled off that page, this one works. But we'll go look at that GigaCalcs, calculator, and see how that works for you. Here, let's see, where is it? This is it? Yeah, this is it. So what you do with this calculator, make sure probability is selected. The probability of guessing a question right is 0.2 in this case. We've got 15 questions, and we were looking for exactly 2. And click calculate, and look what it gives us. It gives us exactly 2. Notice that's the same as on that other calculator. It gives us 2 or fewer. It gives us more than 2. So this would be the bars 0, 1, and 2 would be filled in on that other calculator. This would be 3, 4, 5, all the way up to 15 would be filled in, not the 0, 1, and 2, because we're not including 2. This is less than 2, so this would be only the 0 and the 1 bar filled in, and this would be 2 or bigger filled in. So I'm saying, so it's the same deal. We can just change the number of events. Whoops. Oh, it lets us update it like that. I didn't know that. So there's four, exactly four. So that would be this probability right here. Oh, let me get a pointer going. That would be this probability right here would be exactly 4 that equals. Now let's answer the one 9 or more. So I'll come over here. I'll make that 9, calculate it, and see 9 or more is this last one. It includes greater than 9 or equal to 9. And notice that's that same probability the other calculator gave us. Okay, so depends on what you want is which one you're going to use. Less than or equal to, greater than. Just in case you're a little rusty with that, if I were looking for the probability here, come here, pen. If I were looking for the probability of less than 9, I would want to write it like that. That less than symbol looks like an L. I always used to say L that's been hit by a truck, but it looks like an L. Whereas that's going to be a greater than, and of course, if it has an equal to sign underneath it, less than or equal to. So that would include the bar. Think back to that histogram graph. Okay, so I think I wanted to show you this calculator, make sure it works. My advice is go try some of those worked out. If you want to, do some of the ones by hand and see if you get the answer. Check them with a calculator. You can also avoid doing it by hand with a formula, binomial tables, and just go to some of the ones that Dr. Stevens worked out for you in the text and make sure you can use the calculator for it. Using the calculator is perfectly acceptable. You do not have to use the formulas, right? If it's on a test situation, just screen capture what you got, and you could just screen capture this. You can zoom out, screen capture it, paste it into a document, or upload it if it's in a Canvas quiz, not a WebAssign quiz. Okay. Actually, I think the week 7 quiz is a Canvas quiz about these kind of questions. Okay. All right, I'm going to stop this video and get it uploaded. Give me a yell if you need some help.